In the ultrasonic waves experiment, you will measure the speed of sound through air. The transmitter transmits the ultrasonic waves, and the receiver detects them after they have traveled a particular distance through the air. The transmitter is hooked up to the oscilloscope and is the yellow square wave. The receiver is the green sine wave. When you move the receiver, the green sine wave moves correspondingly. If you move the receiver through one full wavelength, the green sine wave will move through one full cycle. To measure the speed of sound, you will measure the frequency and the wavelength of ultrasound. The frequency can be measured directly from the oscilloscope, but the wavelength is a bit less simple. The method relies on the fact that the oscilloscope can be used to observe the received signal, while the signal from the transmitter is used to trigger the trace. Because of the finite speed of sound, the display is delayed by the propagation time between the transmitter and receiver. Of course, this delay is not known, because the speed of sound is unknown. That's what we are trying to measure. But suppose a particular pattern on the oscilloscope is observed. Here there is a maximum at the center of the screen. Now, if the receiver is moved, the pattern will shift because the time delay is being changed. If the receiver is moved until the pattern is the same as it was before, it follows that the receiver must have been moved exactly one wavelength. We can read the wavelength from the ruler. This technique will be employed for measuring the wavelength, although to get an accurate measurement, you will need to measure over several wavelengths. Using this technique, you will very accurately measure the wavelength of the ultrasound. The frequency can be easily measured using the oscilloscope. Using the wave relation, you will calculate the speed of sound.